Implementing summarization on ABRs and ASBRs. In an OSPF network, you are restricted as to which points of the network you are able to implement summarization at. Unlike EdgeRP, where you can just go anywhere and implement summarization, OSPF makes you go in and say, okay, there's only a specific router, and in this case I'm talking about the ABR like we have right here, which is a dividing point between areas that I'm able to implement summarization on. Now, again, it's not that big of a deal as long as you're very intentional and methodical with how you design and plan your network. So here's what I've got. I've got three routers, router 1, router 2, and router 3. Router 1, I've actually configured 100% in area 0. Router 3, I've configured 100% in area 1 with OSPF. Router 2, I haven't configured at all. It just has essentially two serial links that are connected to router 1 and router 3. Over here, I've got a whole bunch of 10.1. I'll just put .x. It's actually 0 through 7 subnets. On this side, I've got 10.2.x subnets, and that's again 1 through, or I should say 0 through 7, that are represented here, which are going to flood router 2 and flood right over to the other areas once we turn on OSPF on router 2. These links right here are actually 172.16 links. So let me jump on to router 2 where all the action's happening and get started. So I'm going to go to router 2, do a quick show IP interface brief. You can see I've got two 172.16 IP addresses right there. You can see router 1.lab.local sitting out 000, router 3, that's the guy in area 1 on the other side. To implement an OSPF ABR, again, not hard at all. I'm going to do router OSPF 1. Process ID. I'll do a router ID just because I did on the other ones to be consistent of all twos. I'll do a network. Let's do 172.16.1.0.000.255 in area, that would be 0. And then network 172.16.2.0.000.255 in area 1. And we should see two neighbors form. They're good. We do. So I'm going to do a show IP OSPF neighbors. They are now full neighbors, which is fantastic. No DR or BDR showing right here because it's on a point-to-point subnet. That's cool. I'll do a show IP route, and I can see that I am getting all of these OSPF routes from both sides. Now, keep in mind that the ABR is the point of summarization, meaning when I implement this, he's not going to see the summarized routes, or essentially he's not going to suppress the more specific routes because he sees everything from this area and he sees everything from this area. He is just the translator, if you will, that will say, okay, I'm going to suppress these more specific routes as they come over here and vice versa. Now before we summarize, let me show you the perspective from one of the other routers. I've got router 3 here sitting over in area 1. I'll do a show IP route. And sure enough, I see a whole bunch of OSPF routes that are inter-area. And that's the IA. I can do a show IP route. Those are all 10.1 routes. Put a network mask on there and say, show me the longer prefixes. There we go. And we filtered down to where we can just see the inter-area routes that is coming over from the other side. Now, I very specifically chose those routes when I set it up because it's a opportunity for very easy summarization. The way I would approach this is I would say, okay, I've got 10.1.0 through 7.0/24 subnets. What subnet mask would allow me to sum all those up in a single, or I'll say at least lesser advertisements than 8 individual entries? Well, that's where I would come to a subnet mask and I would say, okay, well, it's going to be 255, 255, because those are our static octets. And then this is where the magic happens. We would go, okay, well, let's look binary. We've got 128, 64, 32, 16, 8, 4, 2, 1. Right? That's 8 digits. I had to think for a second there. So 8421's okay. Well, I'm looking at the reason I flipped over right there is I thought, okay, 8 would be a great increment, and then I'll just put 0 over here because if I were looking at 10.1.0.0 as my starting point, 10.1.8.0 would be the next subnet, 16, 24, down and down we go. But we're really concerned with this. So if I had a subnet mask that was this, 255, 255, then whatever this is in decimal, that'd be 248.0. It would actually encompass 10.1.0.0 through 10.1.7.255. My goodness, that's perfect for what we're looking for right there. And it's going to be the same thing on the other side, right? So now we'll come over to the ABR. Router 2. Now, let me do a show run section router OSPF. Again, there's no special command to say you are an ABR. It's just when he has interfaces in multiple areas, it's just inferred. Now I can go in and say global config mode, router OSPF1. Here's the magic command. Area, and you get to choose what area you're talking about. So I'll say area 0 to area 1. I'm going to do a summary route. So I'll do range. Type in the IP address that I want to put in. It says to match, but essentially this is the summary address. So I'll do all the 10.1 networks are over there in area 0. So I'll do 10.1.0.0 with a subnet mask of 255.255.248.0. That one we just found out. And you can see it, by default it's going to advertise this range. You can specify a specific cost and all that. And I'll do the other direction as well. Area 1. Range, same kind of thing. Again, because I did the same thing on both sides. I got the 10.2 networks, 0 through 7 over here, 10.1 networks, 0 through 7 over here. Now let's check it out. I'm going to come over to router 3, do a show IP route this time. At first I was like, oh no, something went wrong. That's actually the WAN link over there on the other side. Right here I see the summary route 10.1.0.0/21. That's the .248. It has suppressed all the more specific routes. If I hit that up arrow and do that longer prefixes, I can see there's only one coming over from the other side this time. I can also jump over to router 1 and do a show IP route. We didn't see this specifically, but it looked exactly the same way. I can see the summary route from the other perspective. Finally, router 2, do a show IP route here, and I will be able to see that I have all of these routes right here, all the specific routes that I see. I told you it's not going to hide it, but notice I have these summary routes, but they're pointed to null 0. What is null 0? It's a garbage can. It's a trash can, right? So essentially this router is saying if I get anything to this network, then I'm going to throw it away, which freaks people out when they first see it. But keep in mind, it just adds this route to the routing table, so it's there, it knows about it, but it's also a loop prevention mechanism, meaning when you're routing, the number one rule of routing is the more specific the subnet mask, the better the route. So essentially, I've got this 10.2 network right here, this 10.2 summary route. As long as I've got the more specific route in my routing table, it will never actually match this. Because if a packet comes in, let's just say I get a packet for 10.2.1.50, right? There's my packet coming in. The router gets it. It's going to receive that packet and go, okay, 10.2.1.50. It looks like this is a match. Oh, actually, sorry, this one right here. This is a match. 10.2.0.0 matches, but so does this one right here. And you know what? This one is a more specific subnet mask, so it's always going to win over this one. So it's always going to send it here unless you have a network where there's not a more specific route, which essentially, I mean, imagine that we didn't have the 7 network. We had 0 through 6, but we decided to use this summary mask anyway, right? So the 7 network didn't exist on this side. Well, that's a good thing in this case because the router's going to receive packets for the 10.2.7 or 10.1.7 on this side of the equation. 10.1.7, it's going to say, well, you know what? I don't have a more specific subnet mask or route in my table, so it's going to match this, which essentially is going to drop the packets. And that's a good thing because we don't want to try and search and find these mysterious networks that really don't exist. That's why we have that summary route to null 0. Now let's change the story a little bit because the other kind of router that can summarize is the ASBR, the Autonomous System Boundary Router, which is a router that connects OSPF to other network types, essentially through redistribution. So let's trash this. Well, not completely. Let's just say this is no longer an OSPF area. This is going to be a RIP network. We've downgraded over there on the right-hand side. So let's quickly configure that up together. I'm going to go to router 3, global config, no router OSPF1. It's out of there. And we'll go router RIP. Let's go version 2. At least give it some features. No auto summary so that we get that out of there. And I will do a network 10.0.0.0. and network 172.16.0.0. So we're running RIP over on that other router. Let's go to router 2 sitting in the middle. Go into global config mode. We will do a router RIP network. Well, let's do version 2, no auto, network. And from his perspective, it's just going to be 172.16. What is over there? I think just 1. 172.16. Oh, .2.0. Well, we're in RIP. I'm thinking OSPF. It doesn't matter. Well, it's a classful style protocol, so we're going to run 172.16.00, and we'll form over there. So let's do a show IP route now. There's no neighbors in RIP. It just starts sending hello, well, not even hello messages, broadcast, multicast with the networks it has, and we can see all those showing up as RIP networks now, right? We are poised to be in ASBR. How do we do it? We go into router OSPF, and I'm going to do a redistribute RIP, essentially, into the other side. We'll set a metric of, let's just say, 20. We'll have a whole, hang on, so that little message notified me. There's going to be a whole nugget on redistribution. For now, I'm just talking about summarization. So essentially, this sends RIP and all the specific subnets that RIP has, otherwise it would have auto-summarized, into the OSPF process. So I should be able to go to router 1 now, do a show IP route, and see all the specific RIP networks. They're showing up as external type 2 networks in the OSPF land, which essentially means it's not going to change its metric. Essentially, I set a metric of 20, and it's going to stay 20 for the rest of the time. Again, more on redistribution later on, but that's the big picture of how an ASBR is created. Now, how do we summarize? Well, it's the same concept from the same place, but different command, right? Because RIP doesn't have areas, so I can't say, well, area 1 summarization is this, because, again, it's RIP. There is no area concept. So we use the command summary address, again, from router OSPF configuration mode, and everything else is the same, right? It's that easy. So we'll say 10.2.0.0, summary mask 255.248.0, and that's it. Again, we can get into tags. There's a lot on redistribution that I could dive into, but I'm holding back. I'm biting my tongue here because that's another topic for another nugget. And you can see right here, this is my summary address. I'll come out and hit the up arrow again, and now we can see all of the outside route, external routes have been suppressed and replaced by a single route, 10.200/21. So that is using the ASBR method of summarization. So you now know how to summarize an OSPF using an ABR or an ASBR method of summarization. I hope this has been informative for you, and I'd like to thank you for viewing.